Uh, okay, then I suppose all the students who wanted to attend this particular session, they have already joined. So let me just start with the uh, from the same place at which we were in the previous class, that is yesterday. So yesterday we were talking about the solution of the heat transfer problem. That was we have already seen the uh, steady state solution. I have explained the program also. And meanwhile, please write your attendance in the chat box. And at this particular moment, I have opened the MATLAB environment. So can actually somebody confirm this thing that the MATLAB screen is visible to all of you?
Yes, sir, visible.
Okay, then.
Yes, sir.
Thank you. So we have already done the some part of the program. That is, the steady state results have been obtained. So there is no need to repeat that particular portion of the program. I would simply come forward to line number 58. So at this particular moment, I have the temperature plot available for the steady state. And you can see that the temperature at the end 2 points happen to be 25 degrees each, because this has been this is the basically the boundary condition. Now in the next part of the program, we will deal with the forward approximation, that is from line number 58 to 73. So I'm plotting the steady state temperature also, which is being stored in a variable known as TST, T for temperature, ST for steady. So that particular temperature solution is going to be used as a reference. And then these particular lines, which are line number 63, 64, we are basically using the calculating the effective stiffness matrix. Okay, you might remember the particular equation which was displayed yesterday. I can display the equation once again. So let me just open that. Just a moment. I should have done that thing earlier. You might have noticed by now that we are using the Zoom platform for the meetings. Of course, this is the free version, and this permits a meeting to be organized only for 40 minutes. That is why the class was left abruptly yesterday. Okay, then let me. So the forward approach is visible to all of you. So I have the specific heat C on the left, which is multiplied by Ti. And there are some other terms which are going to be multiplied by Ti minus 1. Ti minus 1 because it is the known quantity. It is going to be transferred to the right-hand side. And effectively what I'm going to get on the left is the summation of the specific heat, thermal conductivity, and the convective matrix. This is going to be on the left side. And on the right-hand side, I'm going to get the force matrix, Fi. And to this particular force matrix, there is going to be a term which is going to be a multiple of the specific heat and the temperature available at the previous time step. Both of them together are going to form the effective force for the ith time step. So this is what is being done in this particular program over here. So in line number 63, I'm adding a specific heat, that is C, thermal conductivity, that is K, and the convective matrix H. And then in line number 64, I'm adding the force matrix, which has already been calculated previously. That is in outside this particular loop, that is. And in line number 64, the specific heat matrix is also being multiplied by the temperature for the I minus 1th term. So then I get the effective value of force matrix. Then in line number 66, 67, 68, and 69, I'm placing the, what shall I say, the boundary conditions. And then in 71, I'm actually solving the temperature for the ith time step. And I'm storing the result in the matrix, which is known as TFT. T for temperature, FT for forward. So TFT is the name of the particular matrix. And also note that since forward approximation happens to be a iterative process, I'm going to store the temperature values for every time step. So this is being done in a two-dimensional matrix known as TFT. For the time being, the value of I happens to be 2, because when the value of I was 1, all the nodal temperature became equal to the atmospheric temperature. This information was provided as a part of the, what shall I say, the initial values. And then when I is 2, I basically get the solution at the second time step. And then I plot this thing. So let me see if the plot has been drawn. Okay. And then I can share the plot also. So I think the plot is going to be visible. It consists of two lines, two curves, that is, one in red and the other one in blue, somewhere in the bottom. The red curve corresponds to the steady state temperature, and the blue curve corresponds to the temperature at the in the ith step. So as I go on repeating this particular loop for finding the what shall I say, the temperature value for the successive steps, I will go on plotting the temperature also. So in the temperature, obviously, two lines are going to be visible. So the two lines are the corresponding to the two time steps for which the solution has been calculated. And let me do this thing for a couple of more time steps. Okay. I suppose I have done this thing for 10 steps. So there are 10 lines available in blue color. This, I suppose, is visible. Can somebody confirm this thing?
Yes, sir, visible.
Okay, now obviously, as this particular process is going to be repeated, we are going to approach the steady state solution. So we are somewhere approaching the steady state solution. And the thing which also has to be noticed is that as you are approaching the steady state solution, the gap between the two successive temperature curves, it basically is decreasing. So which means that the rate, the temperature changes, the value of temperature change for any particular node, that is getting reduced. And in the extreme case, what we will see is that we have approached the steady state curve. Okay. So this is how it is going to appear like, because it appears to be a bit congested because I have plotted all the temperature values for every time step. But still, what should be appreciated is that we are getting the same solution which we got as a result of the steady state. Now let me cover this thing for the forward also. The logic obviously is going to be clear once you go through go through the theory part. So let me just run this entire loop in a particular go. So this is figure number 3. Let me bring figure number 3 also on display. So for figure number 3, this is almost the same thing as we got for the forward approach. But the results basically have been obtained in this particular part of the program with the help of the backward solution. And then I come to the last part, that is the central. Let me bring the central also on display, which is going to be just a moment. Of the same type. Obviously, you can't make out much of a difference, but let me just plot the converged values. Okay, I am plotting the converged values. So just let me share that particular screen. So in this particular graph, I have the solution for the steady state. I have the converged values because of forward, backward, and the center also. In this particular figure, only one particular line is visible because the temperature solutions obtained by 4 processes. That is the steady, forward, backward, and the central. They are exactly the same. So the end results are getting basically they have been drawn on top of it. Okay, on top of one another. Therefore, you cannot differentiate between the 4 graphs. But otherwise, there are 4 graphs which are available. I can draw them one by one also, but that is hardly going to make any difference. So the thing is that the program is working fine. Obviously, this is something which you expect also. You don't really expect that the temperature solutions of a transient process, which you obtain either by forward, backward, or the center, to be something else when you compare it with the steady state solution. Obviously, this is not what is expected. So this is how the program is working. I'm going to share the program with all of you. I will share it on the WhatsApp. You can copy it from there. And the other thing is, you should try to run this particular program for different values of, let's say we change only one parameter. Let's say that delta T. Okay. So the steady state solution obviously is not going to be affected. It is going to remain the same, but use a different value for backward, forward, and the central. And then you will be able to work it out. You are going to have some idea regarding their performances, which is going to converge faster, which is not converging at all, or something like that. So this is first part of the program. I will be sharing the second part of the program, which deals with the two-dimensional state also, two-dimensional analysis also. But for the time being, if there is anything which is not clear regarding the program which is being discussed, kindly let me know. So, any queries now? Any queries from any one of you?
Hello, sir.
Who's speaking? कौन बोल रहा है? I cannot.
Yes. Sir Chandrakant, sir.
हाँ चंद्रकांत बताइए.
Sir, I'm asking about how you plot the TFT plot, sir, for the recurring time steps.
अच्छा, just a moment.
Because
हाँ, कोई बात नहीं, मैं उसी स्टेप पे आ जाता हूँ. The program is visible to all of you ना? प्रोग्राम तो दिख रहा है आप लोगों को?
Yes, sir.
So I am about to execute line number 61. ठीक है?
Okay.
So in line number 61, the TFT matrix is being initialized. For this particular time step, that is the first time step, the value of TFT is, because we are working with 5 nodes, it is 25 for all the 5 nodes, and the TFT matrix, I suppose, is visible to all of you also. Can you see this thing? 25, 25, 25 written 5 times? Or
Yes, sir.
okay, then thank you. So this is for the first time step, okay, in which the initial condition have been substituted. And at the time being, TFT simply is a column matrix. It is not a two-dimensional matrix. It is a column matrix. But when I execute line number 71, I'm storing the result in the second matrix because because I happens to be 2. So when I execute line number 71, TFT becomes a two-dimensional matrix, 5 rows and 2 columns. And similarly, if I plot this thing, okay, if I plot this thing, then because there are 2 columns involved, I will be getting 2 curves in the output figure. But since at the present, all the values happen to be same, the 2 curves are going to overlap. So that is not going to be actually visible. Okay. But when I plot this thing, तो वो एक के ऊपर एक प्लॉट होता रहता है, ठीक है, तो
Okay, sir.
उसको, या मैं एक मिनट, लेट मी जस्ट गिव यू सम अदर एग्जांपल, जस्ट अ मोमेंट. So the command window should be visible. Let me declare a matrix known as A, and the matrix is 1 is, let's say, okay, I have declared a matrix called A. How I'm initializing that matrix, that is not important, but a matrix of 4 or 5 rows and 5 columns have been created. And when I plot this thing, because there are 5 columns available, I will get 5 lines on the figure. So, so these are the 5 lines. Okay. So the first column corresponds to 17, 23, 4, 10, and 14. So the first curve has been plotted in line number blue. That is 17 over here, 23, and so on. Okay. The plotting is being done column wise. Okay, so this is how it is being done.
Okay, sir.
Chaliye, anything else? कोई और प्रॉब्लम किसी और को? Please take the programming stuff a bit seriously, because this is going to appear in the 2 session tests also. It is going to appear in the end semester examination also. And on top of that, if a company from the campus point of view, from the job point of view, comes in the next semester, then they might ask for students who are well versed with finite element, and then they are going to inquire how much programming you have done, because FEM happens to be a practical subject. Okay, it has plenty of applications in industry, so which can be done only when you can do all these programs. So please take programming a bit seriously, and you can obviously contact me whenever you like. Any other problem? Anything else to be discussed now?
हेलो सर।
हाँ बताइए,
गुड
कौन
मॉर्निंग
बोल?
सर।
हाँ गुड मॉर्निंग, कौन बोल रहा है?
सर जितेंद्र सिंह।
हाँ बताइए।
सर जो आपने यूट्यूब पे लेक्चर अपलोड करा था गॉस एलिमिनेशन मेथड्स, तो उसमें आपने जो प्रोग्राम रन करा था वो कमांड विंडो में रन करा था
हाँ तो
या सीधे डायरेक्टली कमांड विंडो में?
नहीं, मैं समझा नहीं, आप क्या बोल, आप पूछना क्या चाह रहे हैं?
सर आपने जो लेक्चर यूट्यूब पे अपलोड करा था गॉस एलिमिनेशन
हाँ
मेथड सर, गॉस जॉर्डन जॉर्डन,
हाँ तो
तो सर आपने आपने
अब
सर वो प्रोग्राम पहले एडिटर में राइट करा था या डायरेक्ट आपने कमांड विंडो में रन करा वो प्रोग्राम?
नहीं, मैंने दोनों कॉम्बिनेशन यूज करे हैं। आपने अगर नोटिस करा
ओके
होगा
सर।
तो मैंने दो फंक्शंस भी बनाए। ठीक है, एक लाइन इंटर, एक रो
ओके
इंटरचेंज का और एक एलिमिनेशन का। ठीक है, दो फंक्शंस भी
ओके सर।
बनाए हैं, तो दोनों कॉम्बिनेशन यूज हुआ है। बट और एक्चुअल में
ओके सर।
आप लोगों को कमांड विंडो यूज नहीं करनी चाहिए। वो तो एक क्लास का लेक्चर था जिसमें मैं हर एक लाइन का आउटपुट आप लोगों को बता रहा था कि कैसे वो रन कर रहा है। बट इन रियलिटी यू शुड
ओके
डेवलप अ प्रोग्राम इन द स्क्रिप्ट ओनली। चलिए,
ओके
एनीथिंग एल्स? These are some of the methods which are going to be available when you are solving the uh, matrix which you are going to derive by using FDM or FEM. आप गॉस एलिमिनेशन भी यूज कर सकते हैं, इनवर्स निकाल के भी सॉल्व कर सकते हैं। यू कैन यूज गॉस जैकोबी आल्सो, और यू कैन यूज एल यू डिकम्पोजिशन आल्सो, एंड देन क्या बोलना चाहिए, एक तो हाँ, गॉस सीडल भी यूज हो सकता है। ठीक है, टीडीएमए भी यूज हो सकता है। So there are plenty of options available. The thing is, you should choose the best possible solution. That is the solver using the on the basis of the type of matrix which you have. For example, if you are working in a one-dimensional case, working for a one-dimensional problem, the coefficients are going to be along the three central diagonals, three major diagonals. For that particular case, you should solve these equations with the help of TDMA algorithm. ठीक है, तो TDMA आपको आना चाहिए। ठीक है, एग्जामिनेशन में पूछा जा सकता है। एग्जामिनेशन में यू कैन आस्क, एक्चुअली बी आस्क्ड टू डेवलप द मैट्रिक्स एंड सॉल्व इट विद द हेल्प ऑफ द TDMA algorithm. ठीक है, चलिए, एनीथिंग एल्स? कोई और चीज? We still have 5 minutes at our disposal. We can utilize that. Any other thing to be discussed? Okay, then in that case, let me just wind up this particular class for today. And please notice that I have posted a couple of lectures. I think I have posted 2 lectures on the topic of FEM. The second lecture was shared yesterday, I think. So please have a look at both these 2 lectures. We will be discussing these lectures tomorrow. Okay. So that's it for the time being. Have a nice day. Thank you.
Thank you, sir.
Thank you, sir.